Alright, I just want to show you a short video on nonlinear data. So I already showed you this at in an earlier video where the dark line is your observed data. And then if you fit a linear regression equation to this, right, this would be the best fit line. And you can see that it really doesn't do a good job of fitting to the data. So again, that's one reason why you always plot the data, to make sure that you can observe its shape, you can observe its form, and figure out, is your data best fit by something linear, a linear model or not. So I actually just ran a regression using the Excel data analysis regression in Excel, and here's the output. So if you look at the multiple R and the R squared, they're actually decent, right? So the correlation between the variables is 0.05. The model fit is about 72, so 72% in the outcome variable, right, is attributed to the model that we have. So these are actually really good indices. And even if we look at X, right, it is statistically significant, so is our F statistic, right? So what this is saying is even though the fit index, right, is high and the p-value is significant, the simple linear regression is not appropriate for this data. So this really goes to show that sometimes you might just have your data and you just run the regression and you're like, oh, here it's significant, this is good. That's not always the case, because this is showing some significant results. You got some good fit indices, right, in terms of the coefficient of determination, but clearly this model does not fit the data well. And in fact, if you were to use this for prediction, like I said in the other video, right, you would not be doing a good job in a lot of the scenarios. So like if you were to say, like, if this were the pizza example, hey, a student population of 5, what can we expect for sales, right, you would be predicting somewhere around $40,000 in sales per quarter, when really it's less than 20. So that would be a really bad problem for predictions. So when it comes to any type of analysis that you have, always plot your data, right? Make sure that your model is appropriate. Something else you want to do, you can read about this more in the textbook, but you really want to look at your residuals. So remember, your residual is the difference between your observation and your predicted value, right? Those residuals can be extracted and then you can plot them. So these are the residuals plotted. If your data really aren't violating any assumptions, typically they're just random. All your residuals are random. But here they're not. You see a clear pattern. Right, so this is an indication that you violated some type of assumption. In this case, we're violating a huge assumption. We're assuming that the data are linearly related, but in fact that they're not. Those are some things you want to do, right? Don't just run the regression model, right? Plot your data, look at it, look at your residuals, see if the model's appropriate. If not, you have to do something else. So like I said, in this class, we're not getting to nonlinear relationships, but in the upper level business analytics course, we will talk about it. But for right now, at least you would know that if you have this model, you'd know that it's not appropriate and you'd have to do something about it.